Okay, simplifying expressions with exponents. Now, when you look at a problem, you want to make sure you know what your operations are. So you have x, and then the 4 is a power, so I like to circle the power. And then times x, and that's a power, so circle the power. Okay. Now the base factors I have x, and then rather than writing another x, okay, we are going to add the exponents, okay? Don't repeat this, because if these are the same exact factor, x and x, we can just add the exponents. So we have 4 plus 2. And 4 plus 2 is 6. So that's x to the 6th power. We can't simplify that. So that's going to be just the answer I write down over here, okay? I don't know, I don't have a number to replace x, so I just keep it x to the power of 6. Now the next one, we have a y to the 9th power. See how I'm circling that? Times y. Okay, so my two factors are identical, y and y. So I write y down once, and I put a plus sign. So this y here would be a 9, and this y here would have an exponent of 1. Okay, so I put a 1 there, and it's 9 plus 1. 9 plus 1 is 10. So it's base y to the 10th power. We can't simplify that. Now, in my next problem, y to the 3rd power times y, and then I'm times y to the 3rd power. Okay, so I got times and exponents. So my factors are y, and there's another y, so I put a plus, and then there's a third y, so I put another plus. Leave yourself some space in between. So the first y is to the power of 3, and my second y would be to the power of 1. And my third y would be to the power of 3. Notice how none of these are in parentheses, so I just bring down the powers that are there. So 3 plus 1 plus 3. Well, 3 plus 1 is 4, plus 3 is 7. So we have base y to the power of 7. Okay. Next problem, a to the 4th times a to the 3rd. Again, those powers, those exponents I circle, times a to the 10th. Okay, so my factors are a, another a, so I write a plus, and then a third a, I put another plus. You need to leave yourself. So in front of the first plus, I put 4, and then in between, I put 3, and then I put 10. So it's 4 plus 3 plus 10, and that's 17. So it's a to the 17th power, and we can't simplify that. Okay. Pretty easy on the first page. Now let's go to our next page. We have base x to the 5th power, then we have another power outside of a parenthesis. It's a quantity x to the 5th, then outside the quantity, the parentheses, we have a power. So when I say quantity, I mean parentheses. So pretty much the only factor we have is x, but you don't add, because that's the only x we have. Okay, that's the only factor of x I see, so I do not write the plus sign. But this factor of x is in parentheses, so I take its 5 and I distribute it to the 2. So it's essentially the distributive property, which means times, so it's x to the 10th power. And that'll be my answer, x to the 10th power. Okay. Next, we have a base y. We have a quantity. Inside the quantity, we have a y to the 4th, and then outside we have a power of 6. So y is the only factor I have. I do not put a plus because there's not another y. That's my only y. But to figure out the y's exponent, we have to take the 4 times the 6, and 4 times 6 is 24. Okay? So y to the power of 24. Since y is a variable, I can't figure that out. Okay, now my next problem. 5, you want to write 5 times x, and then in the quantity, and then I have a power of 2 outside the quantity. So my two factors now are 5 and x. So I write down 5 times x. Okay, now I'm going to figure out the powers on the factors. Now up here the 5 would be to the power of 1. And it's in parentheses, so it will not stay to the power of 1. I need to take 1 times 2. 1 times 2 is 2. Okay, then my factor of x, its power would also be a 1, and that's also in parentheses, so it doesn't stay to the power of 1. I take 1 times 2, and that's 2. Now, I can't do anything with the x to the second, but I can simplify the 5 to the second, okay? It's not 10. You don't take 5 times 2. You take 5 times itself, and that's 25, okay? So I'm replacing this with 25. So I put 25 times x to the second power, okay? Okay, my next problem, we have 7x, that means times x, and then xy means times y. Okay, and then we add that in a quantity to the power of 2. So my factors are 7x and y. We're not putting any pluses because they don't repeat. Okay, these are the only factors I have of 7x and y respectively. Now the 7, a 7 doesn't have a power, I apply a 1, and that is inside of the parentheses, so it will not stay to the power 1. We take 1 times 2, and it's 2, so it's 7 to the power of 2. Now the x factor, would have a power of 1, and that's also in parentheses, so we don't keep it to the power of 1. We take 1 times 2, and that's 2. And then the y, power of 1, 1 times 2, and that's 2. Okay, now, I can simplify this, but I can't simplify this, and I can't simplify this. So the 7 to the second I need to replace. So I take 7 times 7, and that's 49. So I have 49 times x to the second times y to the second. Okay, next page. I have a quantity first, and then I have a 10 times x, and then x is to the second, and then there's a second power outside the quantity times x, and then a second power. Just circle your powers. So if I ignore the powers for a second, I have 10, factor of 10, a factor of x, and then another factor of base x, which means I just add to the first base x. Okay. So now let's look at our 10. Okay. Now 10 up here, its power would be a 1 since it doesn't have a power, but it's in parentheses so it doesn't stay to the power of 1. We take 1 times 2, and 1 times 2 is 2, so it's 10 to the second power. Because that 2 gets distributed to the 1 and to the 6. Now I go, before you fill this out, find your two x's. You'd fill this in and fill that in. So here's the first x. Now it is to the 6th power inside the parentheses, but the fact that it's in a parentheses means it won't stay to the 6th power. I take 6 times 2, and that's 12. So I have a 12. And this other x has a 2-second power, but it's not in parentheses, so it stays to the second. Okay. All right. And then 12 plus 2 is 14. So 10 to the second I can simplify. The x to the 14th I cannot. So I take 10 times itself. It's not 20. 10 times 10 is 100. Okay, so I have 100 times x to the 14th power. Okay, my next problem. Put in the operators, times m, and then a 4th power, a 2nd power, and then m to the 3rd power. So now just ignore the powers for a second and look at your factors. You have 8 multiplied by m multiplied by another m. So rather than write another factor of m, I'm just going to be adding the exponents. Okay, so 8. Here's 8. Its power is 1, but it is in parentheses. So I don't keep it to the power 1. I need to distribute to what's outside the quantity. 1 times 2 is 2. Now the m's, where are your m factors? We have one here and here. So to fill in the front side before the plus, I have m to the 4th, but that's in parentheses, so I distribute the 4 to the 2, and that's 8. So before I have 8. Now this other m is to the 3rd power, but it's not in parentheses, so then that m will keep its 3rd power. And I take 8 plus 3, which is 11. So 8 to the 2nd power can be simplified. The m cannot be. So 8 times 8 is 64. So I replace that with 64. We're going to have 64 times m to the 11th power. Okay, next problem. 6 times d to the 2nd power times, and then we have a quantity, and in the quantity we have 2 times d to the, that's a 5, fifth power, and then a fourth power. So my factors, I have a 6 times a d times a 2, and there's another d, but I don't write times d because I already have a factor of d here, so I will put a plus. Okay, so let's talk about the 6. Now you got to be careful here. You have 6 to the first power, but that is not in a parenthesis, so then that will stay to the first power. Don't take 1 times 2. It is not in parentheses, so you pull down the 1. You got to concentrate. Now the d, must be 2 of them right here and right here. So this d here is to the 2 power, so I don't multiply it because it's not in parentheses. It's 2. And this d here is to the 5th, but that is in parentheses inside a quantity with a 4th power outside the quantity. So I take 5 times 4, and that's 20. So what's 2 plus 20? It's 22. So the d is to the 22 power. Now I find my factor of 2. It would be to the 1 power, and it is in parentheses, so it should not stay to the 1. I distribute 1 to 4. This 4 has to be distributed times 5 and times 1, not to the 2, to the 1. That's why you need to put a 1 there. Alright, so I can simplify this, but not this and this. Okay, so 6 to the first, we know that's 6. Okay, anything to the power of 1, any base of power of 1 is just the base itself. Now 2 to the fourth, it's not 8. That's 2 times 2 times 2 times 2, and that's 16. So I need to put the 6 with the 16 with the times. Okay, 6 times d to the 22nd times 16. Multiplication, the order can be switched. So I would want to put the 6 times the 16, and then put my variable d with its exponent last. Now you got to be careful because now you need to times the 6 by the 16. You can't times by the variable, but you take 16 times 6, and that's 96. So that's your answer. 96 times d to the 22nd power. Okay, next problem. Okay. Times there. Anytime I'm simplifying, I need my operations times. And then these are powers. 2 quantities though. So I have a factor of 20, a factor of x. Then I have another factor of x, which means I should just add on to the first x. So the 20 is to the 1 power. Okay. So 1 times 2 is 2. So it's 20 to the 2nd power. You need to distribute, if it's in parentheses, the exponents, not the base number, the 20. Okay, then x. So there must be 2 of them. So I fill this in, then I fill that in. That's first x, that's second x. So here's my first x. It's to the 3rd power, but it won't stay that way because it's in parentheses. So 3 times 2 is 6. And this x here is to the 7th power, but it's in parentheses, so it doesn't stay that way. 7 times 2 is 14. So 6 plus 14 is 20. So we have 20 to the 2nd times x to the 20th. Okay, so the 20 to the 2nd can get simplified, but the x cannot. So 20 to the 2nd means 20 times 20, and that's 400. Okay. So we have 400 times x to the 20th power. Again, we don't have a number for x, so we wouldn't be able to figure that out. Okay. Then, last page, 3 and x, 3 times x, and that's a power. That's a power to a whole quantity, the 3 is. 3 will get distributed to 5 and to the 1 when I put it there. Then in the next quantity, we have 2 times x, and then a 7th power and a 2nd power. So just ignore the exponents. We have a 3 times an x times a 2, and then my other x means I will just add to the first x. So 3, well, 3 would have a power of 1, but it's in parentheses, so it does not stay to the power of 1. 1 times 3 is 3. Then x, there's got to be 2 of them. So here's my first x. It's to the power of 5, but it's in parentheses to a quantity with a 3rd power, so 5 times 3 is 15. So I fill in a 15 there. Then I go find my other x, and that's in parentheses, so 7 times 2 is 14. And 15 plus 14 is 29. Okay. Now the 2, go find the factor of 2. It's to the 1 power, but it's in parentheses, so 1 times 2 is 2. So I can simplify 3 to the third. I cannot simplify the variable, and 2 to the second. So 3 to the third is 3 times 3 times 3, and that's 27. Now I also simplify 2 to the second. That's 2 times 2, and that's 4. Now I want to put the 27 times the 4 first, then times the variable x to the 29th power. Then, of course, I need to multiply the 27 times 4, and 27 times 4 is 108. Okay, there you go. Now the last one. In one quantity, we have negative 10 times n to a power of 2. In the second quantity, we have negative 4 times n, and then a 3 and a 3. Okay. Okay, so I have a negative 10. You want to put if it's a negative, you put it in parentheses. Times an n times a negative 4, put that in parentheses. Another n means I'll add to the first n. Okay. So we got negative 10, negative 10, two n factors where I add the powers, and then a negative 4. Okay, so negative 10 is to the 1, but that's in parentheses, so 1 times 2 is 2. Now, n, there's got to be two n's because we put that plus in. So 1 times 2 is 2. In the other end, we have a 3, and that's in parentheses, so 3 times 3 is 9. Okay. So 2 plus 9 would be 11, so it's n to the power of 11. Now, the negative 4 is to the 1, but that's also inside of a quantity that's to the third power, so I take 1 times 3, not the negative 4 times 3. You've got to put the 1 there, and that's 3. So I can simplify this, not this, and this. So negative 10 times itself, and that's 100. Negative times a negative is a positive. Anytime the exponent is even, that negative is going to just leave the problem. Negative 4 to the third, that's negative 4 times negative 4 times negative 4, and that's negative 64. You don't times the negative 4 and the 3. Okay, so we put the 100 times the negative 64, and then last times the variable factor n to the 11th power. Then I multiply 100 times negative 64, which is negative 6,400. Okay, it's negative 6,400 times n to the 11th power.